So we now know how to get a line of position using a sunshot based off of all of this math here. Now it's important to know that the body here doesn't need to be the sun. It could be anything in the sky that you can take a measurement off of. So that could be the sun, it could be any star at all, but particularly the 57 or so major navigational stars that are most well documented. It could be the planets, and when I say planets, I mean the ones visible to the naked eye. So Jupiter, Saturn, Mars, Venus, and technically Mercury, but Mercury isn't listed in the Nautical Almanac. I think it's just too faint to be seen consistently. So this could be anything. However, those different bodies, there are idiosyncrasies with how they work. You need to understand them separate. Oh, sorry, it could also be the moon, but the moon is a whole other thing. Anyway, for each of those bodies, there are extra steps and slight differences that you need to be aware of when you're taking a shot of them so you can do it accurately. So we're going to start now by focusing specifically on stars, because all stars have the same difference between them and how the sun works. And if you remember in the almanac, in the daily pages, you can see that while the sun just has two columns, one being its GHA and one being its declination, and you work between the two and then add in the increments and the increments corrections. When you look at stars, they're more complicated because you have the stars here, but all it does is it lists each star individually, each of the major navigational stars, alongside something called its SHA and its declination, but it doesn't correlate them with time. Now, like these columns don't refer to the hours that they're apart from, they're just listing each star separately. The reason for this is because a star's declination does not change substantially in a given day. It stays more or less the same. If you switch to the next 3 days prior, these values will be ever so slightly different, but the difference will be be measured in decimals of a minute, sorry. So they're not changing substantially, and neither are their SHAs. What's helpful about that, though, is because they're not all changing at different rates. Every star in the sky is fixed amongst each other. The stars move, but the stars move as a whole. That's why the constellations are always the same. If the stars moved independently, there would be no constellations. They would just constantly be moving in and around each other. You wouldn't be able to make any shapes out of it. So because they all move as a whole, we can just set a single point that we measure off of as I almost said the North Star of it, but that would not be a helpful descriptor, as essentially just the point zero, the origin for this grid here of all the other stars. And so what we use as that central point is the first point of Aries. It's, I think, just the most westward point of the constellation Aries. And so every star's position in space is defined off of Aries's position. Declination is still defined off of the equator, obviously, but it's still going to change consistently enough that you can just measure it here and know that this declination for Avior is going to be south 59 degrees, 27.1 minutes for all of these 3 days. And you don't need to worry about that. SHA tells you how far away, well, I'll just get into it. The SHA stands for Sidereal, I hope that's right, hour angle. I think that's right. Might just be an E. Either way, sidereal just refers to Aries, meaning the SHA can be thought of as the GHA to Aries. So instead of measuring the westward distance from the star to the prime meridian, it's the westward distance, from the prime meridian to the star, it's the westward distance from the first point of Aries to the star. As a consequence, if Aries has its GHA listed, which it does have listed all throughout every hour of every day, and you can treat it like the GHA of the sun, you could just take the GHA of Aries, which is sun to Aries, and the SHA of the star, which is Aries to the star, add them together, and you get sun to the star. And that's how we find the GHA of a star. To map that out graphically, I'm going to make that bigger. Okay. We'll make the same diagram we usually do. There's the South Pole. Here's us. In this situation, us doesn't even matter that much. But let's say here's Greenwich. And here's the anti-meridian. And let's say here's the star. So now we're not worried about the sun anymore. We're worried about the star. How do we find the LHA? Well, we know that the longitude is this. Our longitude is that angle. And we know our LHA is this angle. We know the GHA of the star is this angle here. So in this case, LHA is equal to GHA minus assumed longitude. Problem is, we don't know our GHA because it's not listed in the book. That's not something that's provided. What we are provided is the GHA of Aries and the SHA. So let's say Aries is here. And by the way, the symbol for Aries, because Aries is the ram, right? That's the ram constellation. It looks like a stylized little like sheep's or ram. So if that's Aries, right there, then we know that this is the GHA of Aries, because that was provided in the book, and this is the SHA of the star, the westward angle from Aries to the star. So while we know that LHA is GHA minus assumed longitude, we know that GHA of the star is equal to GHA of Aries plus SHA of the star. And conveniently, if we draw another diagram, we say we're here. But this time we put Greenwich over here. And let's say the star is still over here. Even though now this is longitude and this is GHA, meaning in this case, LHA is equal to assumed longitude plus GHA. Actually, you know what, let's make it even, well, we'll just do it here. If we put Aries here, then here's GHA of Aries, here's SHA. So GHA of the star is still equal to GHA of Aries plus SHA. GHA of Aries and SHA of the star are both westward distances. So it doesn't matter if you're in the east, it doesn't matter if the star is in the east, it doesn't matter if Aries is in the east. You always just add SHA to the GHA of Aries, and that gets you the GHA of the star automatically. It doesn't need to be any more complicated than that. Even if the GHA of the, I'll take a new page so we can see more clearly. Even if Aries is in the east, so let's put ourselves back in the west. Here's Greenwich. And let's say Aries is over here. And the star is somewhere over here. The GHA of Aries is this, which is more than 180 degrees. It's a large number. And the SHA of the star is this, which in this case, it happens to also be more than 180 degrees. So if you add these two together, what you get is that right there. It's more than a full circle. So you would think that that doesn't help you, but it really, it's fine. Because what you can just do, if this was Greenwich the whole time, you can just say this whole portion right here doesn't matter. This is an additional 360 degrees. That is not important. And you can just cut it out and then measure only this portion. So in situations where you're measuring SHA and GHA, you could get a number of like 430 degrees as your GHA of the star. That's fine. You just subtract 360 from it, and you're gonna get, what, 70 degrees? Yeah, 70 degrees. And you could just say your GHA of the star is 70 degrees. Anytime the GHA comes out to more than 360, just subtract 360 and you get back down, because we're just going around in circles, so it doesn't matter. So in review, when you're measuring the star, when you're doing the work for a star, all you need to do is find the GHA of Aries and the SHA of the star. The GHA of Aries being listed here, just like for the sun, where it's just by the hour. And then the SHA of the star is listed here. And you just add the two together and you get the GHA of the star and can continue like you did before. The declination, you don't need to do any interpolation for because it moves so slowly that you can just use whatever's listed here for the whole page. Now finally, really briefly, the only other difference between stars and planets, or between stars and the sun, is instead of using this section for the altitude corrections, where you worry about the time of year and the upper lower limit of the sun, for stars you just use this column over here, this box that says stars and planets. Makes it nice and easy for you. You ignore this side and you just follow this down, and it works the same way. Dip, you'll still use this table. So the only difference between the stars and the sun are including SHA, not worrying about interpolating for declination, and using this column for the altitude correction. So we'll try an example of that soon.